so much I could have said, but I wasn't ready then, and I'm still not.
All right, so Claudio and Melissa, please start.
Okay, awesome. So first, welcome everyone to our event. We are so happy to have you. First, we can start by introducing ourselves. So I can go first.
Yeah.
My name is Claudio Alcazi. I'm a graduate research assistant at Polytechnic Montreal, specializing in AI-powered 5G wireless communications. I am also the industrial workshop coordinator and marketing manager at IEEE Young Professionals Montreal. And yeah, first I would like to thank IEEE ULFG2 for hosting this event with us. So this is our first and hopefully not the last collaboration with you guys. And it's been an honor working with you and to make this event happen. It's been a pleasure, and thank you, Melissa, for your hard work. And if you'd like to introduce yourself right now, go ahead.
Yeah, thank you, Claudia, for this warm welcoming. I'd like to introduce myself. My name is Melissa Akiki. I am a third-year electrical engineering student at the Lebanese University Faculty of Engineering, Rumie. I am also the vice president of the IEEE ULFG2 student branch. And I think I'm very excited, like Claudio as well, for this collaboration. It's one of the biggest ones we're doing this year, and hopefully it won't be the last. And I'd like to add something, if you don't mind, Claudio, to focus on the Lebanese roots of our speaker, which makes us very proud, like
Oh, of course.
Lebanon. Yeah,
You should be.
yeah, like to have a speaker coming from Lebanon, also, you know, a bright Lebanese abroad. Yeah, that's it for me. And also welcome everyone.
Okay, awesome. So now we'll go on to our guest speaker. He's a computer engineer at the University of Central Florida. His demonstration of both great aptitude in his field and leadership and organization skills led him to be selected by NASA to work as an aerospace scholar, where he worked on various projects that he will share with us today. He then started receiving funding from NASA to work on his own ideas, most notable of which is the CubeSat holding plant, which he's developing at the Kennedy Space Center. He is also working on extended reality applications for the US Naval Air Warfare Center. So he is a very good friend. Nicholas, we're glad to have you with us.
Super
welcome.
Proud.
Thank you. Thank you for having me, Claudio, and thank you everybody else for attending. Also, let me know when I can share my screen, just so,
you can't?
just so I know. And if I have sharing privileges, I feel like, yeah.
No, you're co-host, Nicholas. You can.
Oh, okay, perfect. I'll share my keynote right here. Thank you for the introduction. I've never been introduced that way, so I really appreciate it. But Claudio and I, we go a way back, and I'm really glad to have done it with him specifically, and I'm really glad that I met all of you, the team, and the team has really put in a lot of effort to make this happen. So I really appreciate all the time and effort and dedication that you put into this. This has been in the work for for a few years now. Not this, but this collaboration with me and Claudio, and the whole team has put in months of effort to try to make it happen. So I really appreciate everything that you've done. So to start off with the presentation, we're going to be covering NASA systems engineering today. And it's an overview of the project lifecycle, right? So does anybody here know how to raise their hand on Zoom? Is that something that I feel like people, let's see if people
I
can
could
raise their hand.
assist.
Yeah.
They just have to press on reactions, and there is raise hand. There is hand. There is like in the bottom, like an icon for reactions. You
Okay.
click
I
it, and
see.
there
I
is
see your
one
raised hand.
raise. Yeah,
All
yeah.
right.
There's
So
a
I just
raise.
want to ask. I just want to ask who's familiar with systems engineering and project life cycle? Just the terms. Anybody? Anybody know what I'm talking about? Okay, we have a few hands. We have a few hands raised. All right, good. That's great. That's fantastic. All right, thank you. All right, so let's start off with some introduction. So I hope you like the animation. But yeah, so some background about myself. I was designed in America, but I was assembled in Lebanon. And so, I grew up with Claudia. We went to the same school, and uh, I came here to study computers, right? I study at the University of Central Florida. This is our stadium, and our stadium at the 50-yard line, that's right in the middle of the stadium, it has the same altitude as the as Kennedy Space Center's launch pad 39A, and that's where they launched to the moon. So whenever they launch stuff, I think this is a SpaceX rocket. So whenever they launch anything from 39A or anything from Kennedy Space Center, we get to see it right from the stadium. So it's a really nice viewing point. And that really got me interested in permanent settlement in space and extended reality. And so that's what I'm currently working on. But some of my previous projects have been around waste management system. So that's for environmental control in deep space habitation systems and prototype Mars rovers. So you're familiar with the Curiosity and Perseverance. My team and I designed a prototype at Kennedy Space Center for that. So an asteroid lander also that was in regards to I think Marshall Space Center, and fused deposition modeling also for sustainable supplies. So you want to think packaging and deep space habitation systems. The asteroid lander was part of the Lucy mission, so I studied asteroids for a while, and some non-space related things, which I also I'm also a big fan of, are machine learning models. I developed machine learning models to predict COVID-19 deaths, and a productivity app and a website for priority checklists. And the reason why we focused on that is because astronauts in space use the priority checklist to get all of their tasks and goals done. And so we thought this was a very important asset for the consumer public to be able to utilize. And so some of my current projects, as Khalid mentioned, are fully sustainable plant habitation system. So my team and I are currently developing a CubeSat design. So that's a 6U CubeSat in dimensions, and it's going to hold a plant and around a lunar orbit. And it's going to take a while for it to be launched. We're currently in phase, I would say A. So we're pretty early on, and you'll get to see the phases as we progress in this talk. And so extended reality is also one of my interests, and currently working on a policy for the Navy. And so those are currently what's how my time is divided. And so what I hope from this talk to share with you, why I'm sharing this talk, is because I noticed that there's a need for it. So I joined some teams, and people were very excited to be part of the development of space and exploration of space. But they like insight on some, I would think, major and very important topics, some of which are two things: systems engineering in general, and project lifecycle. So they're great engineers, and great scientists. But understanding how the product evolves over time is something very important. And so what I hope by the end of this talk is that you become like eagles. You soar really, really high, and you're able to see the landscape from a really far away perspective, right? And then when you notice what you need to focus on, you dive really deep and really quickly. And so bald eagles can dive up to 100 miles per hour, and golden eagles can go up to 150 miles an hour. And they can go from anywhere between 10,000 feet to 20,000 feet from sea level. And so I hope by the end of this talk, you're able to see the system as a whole, the big picture, and then zone in on the part that your team is focused on. So you're able to meet deadlines and you're able to meet requirements. And so that's what I hope by the end of this talk. And so here we go. Here's the engine, right? And I don't mean an actual engine. This is a metaphorical engine. But the requirements flow down from here. And we're going to focus on this part for a little bit, right? And if you see me just looking away, glancing away for a little bit, I do have some notes because there's some things that I want to cover. And it could be a little bit intimidating, right? When you first look at it. So first off, a formulation, right? And so we have the system design processes, and that's when the stakeholders, people funding your project, or even people higher up in the hierarchy, you get hold meetings, and they talk about what are the expectations, what are the overall objectives of this project, why are you undertaking it in the first place. So then from there, you can start getting an idea out. So this idea will then formulate into a concept, right? And so you might have some technical requirements definition. What that means is you're starting to maybe think of things to consider, right? If you want to design, we're gonna take two examples throughout this whole talk. And one of them is going to be something that you're very familiar with, which is the Apple iPhone. And the second one is the what I'm working on is a little satellite, right? And so if we're looking at a satellite and an iPhone, and how do they compare and contrast, right? And how would you approach developing both of them? Well, if you're looking at the stakeholder expectations for an iPhone, you might think, okay, you want to develop a phone, a way to communicate, and a way to explore. And then you might set some requirements that it has to be handheld, has to fit in your pocket. It has to, tell you when you're being called. So it has to connect to something, right? And you have to be able to use it every single day. So these things are very top level expectations, right? And top level requirements that you're defining. So what I mean by top level is you're not going into any detail. You're not choosing parts now. You're not choosing anything like that. You're just defining what you want to achieve. And I think that's at the top level, everybody should be on the same page. All right. So then you start going into, okay, well, does it need to have a battery? You might start thinking these things. And that's going to take you from the technical requirements of, I need an actual, what do I need to build it? What do I need to prototype it? Do I need a facility? Do I need a team? How big can I get the team? How long do I want this project to be? Is it going to be 1 year, 2 years that I'm going to be in development? So you're starting to think about this whole thing just from a really far away perspective, right? Okay. And then you start going from really high up, really top level stuff, and you start breaking it down, right? And when you start breaking it down, like, okay, I'm going to be able, I want to use this iPhone every single day. What does that mean? That means it should hold a battery, and the battery can recharge every day. Okay. We're not going to go too much technical detail yet about the battery and the constraints on the battery and things like that. But you know that there's a battery now, and you know that there's something holding the battery. And you know the battery is going to be connected to something else that's going to interface with the network. And you also know that there must be a display, right? So those are part of the technical requirements. And now you're breaking it down, and in a logical decomposition way, in a way that you're able to more clearly define the role of each part or the role of each subsection, right? And so you're having analysis with other scientists, and so that's going to greatly impact your design, right? And so if you're trying to also ship something into space, in comparison, you might think, you also need a battery. Or where is it getting the power from? Is it solar panels? Okay, if so, it's storing it in a battery. If so, what are the volume constraints that you're facing? Because you only have so much space and so much mass that you can put out. So that you're going to want to consider that, right? So those are kind of top level things, but those are very important stuff when you want to dissect the system, right? Okay, so you're also looking at how complex it can be, and you're trying to define that. Maybe put some lines where people can see the complexity and how deep can you go. So through this whole talk, we're going to be talking about how you can go down and then working your way back up. So you're going down as in you're trying to find what each and every part composes this whole system. And then once you have those clear and defined, and now you have subsets of teams, then you can work backwards in testing, integrating, and then operations, and then close it out when you finally finish out, right? And so you also need to have, so now we're on step 4, right? A design solution. So you want to be able to have this system sketched out, like a little, sketch, so everybody's on the same page and they know what product they're building. They know where they fall into the product, right? You might be a software person, you might be a hardware person, you might be a scientist, yeah, right? And so you want to focus on, okay, this is where I fit in. I see what I can develop. I see what teams I need to work with. So you're starting to get another idea on the project, right? So we're going to focus now on the right-hand side, and we're going to go from the bottom up. As you can see, the numbers increase from number 5, so the product implementation, right? So now this is a design realization. So now you might start having things like prototype, right? And you might have little parts selected that you're analyzing, right? And you're testing, and the right-hand side is more of you're building now. You're more than just researching. You're more than just in the gathering stages. Now you're actually implementing. So you're going to have a prototype, right? And you're going to have some way of testing it, and then some way of integrating it. And that's step 6. So you're starting to choose parts. You're starting to head over to the lab and starting building things. And then you're going to go into verification. So verification that these parts actually perform the way I want. And these parts are actually fit in the constraints that I need and the requirements that I put out. And you're going to hear these terms a lot. So I want to make sure that everybody's on the same page with them. So requirements are what you define as what the project needs to accomplish. And the constraints are the resources that you're limited to. So the constraints, for an iPhone, for instance, are that it has to be in a size that you could put in your pocket, and the weight of it can't be too hard that you're treating it like a dumbbell. It needs to be rather lightweight so you can put it up to your face, but at the same time, it won't, put a hole in your pocket when you're carrying it around, right? And you don't need a specific carrying case that you're carrying it with, because trying to shove a lot of stuff in, like a display, antennas, battery, charging ports, other types of ports, back in the day, right? Buttons, if any. So those all factor in, and you might think, oh man, I need to develop some stuff in-house, or I need to, kind of expedite this technology. I need to work on it to get it up to par on what I'm trying to build. And so you might think, man, this is a few years down the road that I'm, going to be able to build this thing, because maybe the battery isn't as good. Maybe the display is a little bit too old, so you can't fit that in. So you got to start laying out what you can and cannot do. And that's very early on. That's on the left-hand side, but that clearly ties in with the right-hand side of when you're now going ahead and buying parts. Can you go ahead and buy a part that gets the job done? Or do you actually have to build one in-house? Maybe you need to take a part and retrofit it, trying to change it up a little bit. So I'm tying the left-hand side with the right-hand side, and actually that's what systems engineers do. There's a lot of management, as you can see here. There's like, it says management like 5 times, right? So these guys, they tie in the theoretical with the actual, and they go in and tie the teams together. So like, let's say you did go ahead and you found a display, and the display for the iPhone, you found it to be, this great display, and it allows for multiple fingers, but man, it requires so much power, because a pivotal point of the iPhone was that you can use your finger and not use a pen like this, right, to touch the screen, or one that's actually made for screens. But a touch capacitive display needs a little bit of power, right? And needs the latency to be up to par and stuff like that. So what if you did find one on the market, but man, it's maybe too expensive, or it requires so much more power than you have given to you. And what I mean by that is that the electrical engineers decided, oh, this is what we can do with power. That's what we're going to go for. So you're only allotted to use this much power. You're going to put in a request to go get that part, because it's going to make your job easier. You don't want to sit there and develop your own screen from scratch or something. So you're going to want to try to figure out if there's a way to go grab it from the market, off the shelf part. And so if you can do that, okay. But if not, then they're going to tell you no. Who's they? The systems engineers. So they're going to tie in the theoretical with the actual. They're going to tie in what's on paper with what you cannot build or can build. So that's how this whole engine works, right? And so as you look from 17 or from 10 going down to 17, you're going to see the planning that goes in, and that's the schedule, right? That's the Gantt chart, if you're familiar with it. So it's a schedule of, in each phase, what are the goals, what are the milestones, and what are the teams going to be working on to be able to achieve those deadlines, right? So the systems engineers set out that chart. So it's essentially an overall plan of the project, and then they break it down by requirement management, interface, so the different modules that you're building, how they're interfacing together, the technical risk associated with them. Okay, can I actually have a battery this big? What if it's hazardous? What if it's gonna, melt or blow up like, one of the previous phones from previous years, right? So you might have to assess these risks. And if it's a risk you can tolerate, then sure, you can get the green light and go ahead and build it. And if not, then you gotta reassess. And configuration also. That's when you're working on the design and actually integrating, right? And then the technical data management. What are you doing with the data? How are you processing it, right? So you have to have all of that planned out before before any decisions are made. And so when you want to think of the systems engineers are the interface and how they link people together. And so they're the eagles here. And so you can go on and have technical assessment. If you're going to actually assess the technicalities of what you're building, right? And that you can get approval for. It's procurement. It's all about building, integration, and testing, right? And then decision analysis. And you can have that implementation once everything pans out, right? And so something very important to keep in mind is that everybody's working with a specific baseline. And those words that I'm saying, just keep them in mind because you're going to hear them a lot once you go ahead and start working with larger and larger teams. You're working on a baseline. And that's when you consider, that's what you're trying to meet at the minimum viable product. So what's the least amount of things that it should do? It should charge every day for a year. We're still talking about the iPhone, right? It should charge every day. It should be able to last you the whole day, right? You should be able to touch your screen however many times. You should be able to plug and unplug the port that many times for you able to charge it. So those are the baseline. You're developing, okay, this is going to work for 10,000 times. Besides that, it could work and you could make it work and things like that, but that's what you're going for. That's my baseline. Everybody's on the same page, you start building. So ensure you have those. And how you're spending money. So that's at the, if you want to consider that the baseline, how you're spending money and how much time is required to do all of that. So that all ties in with the system engineers. Constraints also, we went over that. And the resource allocation is something that you don't want to forget. So what resources are allotted to you, right? Okay. Okay, so this is the engine. And any questions before we move on to the next phase? Do we have something in chat? I see bubbles. I see red bubbles.
Nicholas, I just want to make sure that we're on the same page before going on to more complex ideas. So it's like
sure.
on the left, it's like a tug of war between people who are trying to figure things out theoretically and people who are actually going to implement and buy the stuff that we need to create the project. So people on the left want to do whatever it takes to be able to create the project, and people on the right want to find the easiest or the most financially feasible way to do that project. And the system engineers, like what we're trying to discuss right now, are the people in the middle who try to balance out between the two and try to communicate between them. Okay, which theoretical ideas are feasible with the money? How much minimum amount of money and resource allocation can we provide so that we can create this minimum viable product that was given by the theoretical part? So this is like the goal of the system engineers, right?
That's correct. Yeah, they tell you what you can and cannot do, and maintain. They keep the tech, the really nitty gritty stuff to the specialized people, and then they see the overarching project, and they have to keep that in mind so that everybody's in place, because otherwise you might be developing something that cannot integrate or interface with other modules. So like, let's say you're building an antenna, and the antenna has a certain, gives out a certain output. The display maybe cannot take that output because the display is connected to a module that doesn't use that interface.
Yeah. Okay.
So everybody needs to be on the same page, so that when you're developing these specific parts in isolation, as in you might be developing it, in I don't know, Marshall, and then somebody else is developing another part in Kennedy. So you're building different parts, but you want them to interface at the end of the day when you put them all together. And if they don't, you just built, useless material. And so you really want the whole project or the whole product to work as a whole, and then testing it individually before you start integrating. So I think that's but yeah, you're right. They kind of tie the theoretical and the actual. Yeah. So any other questions before we go ahead? And for
So
this
I think
talk,
that's
I really
it for the chat. There is Santana who wants to know if she can have access for the slides.
Oh,
Like
sure.
if you're
Yeah,
going to
I can share the slides. Yeah.
Okay.
Yeah, no problem. I can share the slides. All right, that means people like them. All right, cool. All right, so
yeah, so far good feedback.
All right, cool. So here we go. So now the project lifecycle, right? And I'm going to share with you this screen, and don't be intimidated. Okay, we're going to go through it part by part. I'm going to break it down so that you're able to actually digest it, because it's a lot. It looks like a lot. When I first looked at it, it was pretty intimidating, and so I didn't know what was going on or where I fit in, right? And there's a lot of acronyms Claudia, help me out with what was the other word? But
the
okay.
acronyms
There's
and
a lot
abbreviations.
Abbreviations. That was so there you go. Yeah.
Yeah, we all struggle with them.
Yeah. So we're gonna go through them, right? So here we go. This project lifecycle is broken in two. And so there's a formulation part, which is more of the theoretical, if you want to think about it that way, and then the implementation, which is more of the actual stuff, right? Okay, and so we're going to look at the formulation first, and then we're going to take only the first phase, right? And so the first phase, that's your concept study, and that's when initially in the life cycle, you're assessing all the ways that you're trying to get this thing built. So what you're trying to build, let's say you're building an iPhone, you're trying to think of all the ways that you're trying to build it. Does it need buttons? Yes. How many buttons? Maybe in one of your designs, you have 5 buttons. Maybe in the other design, you have 1 button. Maybe in another design, you have 2 screens, one on the front, one on the back, because maybe people will put their phone, facing down, and you thought about that to be something important. So you're assessing all the different ways that you're trying to build what you're trying to build to be able to achieve the goal that you want. Because at the end of the day, you're building a phone with a touch capacitive screen so that it can connect to the network. And remember, those are the things that you put out, and those are objectives, right? So you want to always go back to them, because those are your values. Those are what you care for the most. And so when you're developing something, you want to keep those values in mind. And so they also meet the stakeholder defined system objectives, right? And so those are the things that happen in this pre-phase 8, right? And so also there are discussions now that are going on between you and the stakeholders about what is feasible, what can you do in this time, budget talk, what can we actually build with the with the things that we have, with the labs that we can get access to. If you're trying to build a satellite, it's how much do you think, how many people do you think you're going to need? And you're going to start off with a really small group, but then as you develop, as you go through the phases, more and more people are going to have to join your project so that they can actually get that up and running, and you can like ship it out and operate it and then close it out at the end of the day. So yeah, you're having discussions between the stakeholders. There's a lot of business talk, and there's a lot of system requirements established at that point, right? And you want to have a good understanding with each other. So as you can see, I don't think I can point out to it, but if you look all the way down, where it says supporting reviews, not that. You want to look 2 parts above it, like 2 lines above it, where it says robotic mission project lifecycle. Okay, look at the little triangle that's right next to that, and it
Can you
says
use your mouse?
MCR.
Maybe.
I'm trying. It's just that. Oh, wait, I think I'm able to annotate or remote control. It's just that whenever I'm in this view, I can't view my mouse. So let me just annotate.
Yeah, we can see your mouse. Yeah, okay.
Okay, perfect. So as you can see right here, it's should be a spotlight. Okay. Okay, that's perfect. Oh, that's perfect. Oh, okay,
Nicholas,
fantastic.
we're good with the mouse earlier. Like if it doesn't
Okay.
work.
Does this work? Is this better?
Yeah, we can see it. Yeah, it advances.
Okay, cool. Awesome. So so this right here and right here, this is your mission concept review. And this is also like it's like a scoping exercise. You're trying to see the overall big picture, right? And you're trying to, communicate that with the stakeholders. You're trying to tell them, this is what we can build. These are the different ways that we can build it. And you're going down, in a technical analysis type of way to view alternative concepts, all the different ways to do it. And and they all meet the constraints and the requirements and things like that, right? And so there's also a programmatic analysis of the whole thing. And so what that means is these different concepts, they meet the preliminary cost and they fit by schedule. And you're able to have an initial system, like a concept of operations, which is essentially just a description of how the system is going to work, is going to operate, right? And so this criteria can then be set out so you can develop other designs, and you can then from those designs kind of boil it down to one, and that's going to be in the next phase. So right now we're in pre-phase A. You're doing the concept studies. You're getting all of these ideas. You're going to want to boil that down into maybe just a few, but you really want one, because you really want everybody to be focused on just one design. And so that's what's happening right now. And those are the MCR. And every one of those, you want to think of it as a big paper. You're doing a big document, a documentation that encapsulates everything that you've done so far. So you're thinking of all the different ways you're trying to build. So you better have everything flushed out by the time you're submitting that, because you're going to get reviewed, and there's a review committee. And that's another team that's reviewing your work. And they're going to be like, they're called subject matter experts, and they know their stuff. So they know if you're able to build this or they can predict it at least, build this in that time frame with that budget, and they're evaluating your work, and they're acting kind of like advisors, right? But more like, this is what we're going to tell the stakeholders once they ask us. and we think you're either good to go or you need some tweaking. So if you do need some tweaking, you're gonna go back and really work on those, right? Okay. So right now you have the ideas, and now you want to kind of go from top level stuff down to, high level system stuff. And what do I mean by that? Now you want to clearly define what are the actual things that you want to include and what are the things that you can let go of, right? Because those are things that you might hold tight to, like might hold close to you. And I think we think of that every single day, what you want to carry out with you in your backpack. What are the things that you value the most in that design? And so those are things that you start thinking of once you have the concept and technology development, right? And so that defines the high level stuff. And it has, now here is where you have your baseline. That's where you're like, that's what I care for the most. I'm gonna disregard that other stuff. Let's really focus on that and get that to boil down to really one design. So you're trying to shred out the fat if you want, right? And if you're building a satellite, you might define a few things. Be careful, collection acquisition or data acquisition, right? So data acquisition, data collection, data management, computation, and transmission. So if these are your three main focuses, how do you make that happen in a one design without, losing too much of the other stuff? And what do I mean by that? You always make decisions and compromises. You chose up to work to wake up, let's say at 7, you gave up waking up at 8. That's a compromise you had to make. And so you might gain an hour more in the day, but you lost an hour at night. And so you're willing to make that compromise if your return on investment meets that decision. And so that could be the baseline, that I'm willing to wake up at 7 because I'm able to conduct this work in that portion of time. So that's how, so that's how things, right? So you're defining the primary internal and external system interfaces, right? So how things are going to operate on the inside, how you're going to collect that data on the inside. If you have in my case, we have a plant on the inside. So how we're going to actually get the data from the plant, process it, and transmit it. So there must be some antennae on the outside, or maybe everything's on the inside, right? Because we can't have anything that can affect the system while we're sending it up to space. So you want to really assess how you're developing it. And also, if you have some attitude and orbital controls, right? This is for any mechanical and aerospace. So if you have any of those systems, they're able to interface with the other modules, like the computer on board and the sensors and the camera system and all of that, right? And the antennas to be able to send commands and get data back. And so now you have a top level flow and down to a high level requirements. You're still not going too deep into the details, not getting too much into the weeds, but you're identifying key technologies that are required and that will require investment, right, to mature for flight readiness. And that's what you're essentially looking for. And you're refining the life cycle kind of cost estimate. How much is this going to cost me? How much time do I have to spend on this, right? And you're putting this whole thing, you're putting all the management tools in place, all the risk assessments, all the system engineering processes some of which we mentioned earlier, a lot of which we mentioned earlier. And so you're thinking of all of these things, and you want to include in that, I was going to say document, right? But it's a concept technology development. And so you're really working towards better refining your design, right? Okay. So that's all I want to cover. And then after you have your baseline, right, now we're in the preliminary design and technology completion phase. So you can see right there in the project life cycle, right? You can see the baseline project plan. And before that, there was a preliminary project plan. So here is where you actually really focus on creating the requirements for your design. So what does that actually mean? Moving from the requirements to design and establishing an initial baseline capable of meeting the system requirements, right? So I'm going to make that a little bit more tangible. So from the iPhone, you're generating the detailed requirements at a high level, and that's approved by the SRR. So from the previous section, we have a whole list of things here that I just didn't want you to focus on, because I really wanted to get how we're boiling it down from top down level. But essentially, you have a whole subsection of reviews that teams are going to assess your project, and that are listed in red, right? So that way you're able to generate the requirements that are consistent with those reviews. So you're completing plans for verification and validation of the system. And you're also establishing a preliminary design that's consistent with everything that you've ever built or ever thought of designing. So you're still not in any of the, you're not going to any labs yet. You're still doing research. You're still meeting with teams, and you're completing the technology maturement to ensure all of these technologies are ready for implementation once you actually start building, right? And so developing a detailed plan is something very important. And it's something that you really want to clearly state out and start to break the system into little and smaller pieces. So when you're looking at the baseline, right, that you've been thinking of from phase A, I want to develop this baseline. I want to have all the teams on the same page. I want to make sure that this iPhone lasts for at least a year, because people are paying this amount of money and they expect this return on investment. And then they expect to have this amount of work done in a year for it to actually make sense for the consumer to come buy it. And also, we want to take into consideration how much money do we have to spend on things that aren't really too technical, right? As the marketing team, things that you didn't really consider before, but now that you have a clear idea of what you want to build, you can start incorporating these different aspects of the project that before you didn't really put too much emphasis on. But now you can actually fine tune and start thinking, oh, I actually need some people working on marketing this product to consumers. Or maybe you need another team that's working on how to actually get you the parts to build the product. So a supply chain team. Or maybe you need to build a factory that needs to work on that. So maybe you're thinking of industrial engineers to set the layout for the factory, right? So you're starting to break it down and have more refined subtasks or sub problems, if you want, to be able to achieve your overall goal, right? And so you're going from a preliminary design or a preliminary project, and you're breaking it down into the actual baseline. What do I need at the baseline level? So that's everybody's C level, if you want, right? And that's what you get the preliminary design review. That's one of the most important documents that you're going to put out to be able to get your project up and running. And it's going to have all of your thoughts, all of your tiers. I hope that you print another copy, because that happens sometimes. But so you're going to have all of everything they've ever worked on in that document. And that's going to have your budget, your timeline, the division of work. Everything you can think of is going to go into one design. And you're going to have a few people come and review your work, right? And these are the guys that are going to give you the thumbs up or the thumbs down. And if you give you a thumbs down, you're going to go back, and it's a whole cycle. You're going to work again and improve your design and make sure that you're meeting the defined requirements, and you're in the budget constraints and the time constraints and all that good stuff, right? And so you're developing a detailed plan that includes updated costs and schedule estimates. So that's in phase B. And the preliminary design review, it addresses the high level, internal and external, as we said, and all the required technology maturation. So everything that you can think of, what I need to develop to get to that point, how much time do I need to invest in that, the flow down of how the system is going to operate, right? And then the results of the activities assigned by the team in the previous document. So in the mission design review. So you're always linking it back to the previous document. What did you build there? How did you trickle it down? And how did you include more things in it? That's what's going to end up being your preliminary design review. I've had to do one of those. It's tough, I'll tell you that. But that's the last part before you start, before you get approval. And if you get approval, everybody celebrates, and people start running. Like they start running down to other offices, knocking on offices, trying to get the things set up so they can start building, ordering parts, talking to the right people in the finance department, accounting. It's crazy. You're starting to really, okay, we got the let's go, we're building now. But now, yeah, your phase C is kind of you're going to see in the next part. So so right now we're in the implementation section, right? We finished all of the good stuff. We've gotten the okay. Maybe the stakeholders are like, you got to go back and reassess some stuff, because we thought that maybe just a little bit of thing, they give you some criticism. So you got to go back but you're good to go, but you just got to work on those. You just got to make sure that you cover those parts, make sure that, the design is, although it's fully complete, you're able to execute it and deploy it in the constraints. So they want maybe a little bit of a different design on some little part, not a major redesign of everything, not a system-wide change. You have the design fully flushed out at that point almost, and now you're just tweaking a few things, right? And I want you to keep in mind that if you're talking for space applications, we don't know what rocket it's going to go on. So you're building this whole thing, you didn't even know what rocket's going to go on, right? And so you really don't know what to include so you're able to meet that rocket requirements. So that you're going to touch on when you're assembling the system, integrating it in the next phase, right? And when you're getting ready for launch. And so right now you're doing the critical design review, which is essentially you're trying to focus on completing the system design, building, purchasing the hardware, and getting the software set up, and all verifying all the components that perform, the components, and that these, you're verifying that all these components really perform the way you want them to, and they meet all of your requirements. And so you have the baseline, right? You have the testing and the integration now incorporated in your design. You have all the different ways you're gonna like validate that things are gonna work on Earth as it's gonna work in orbit and on launch. So you're gonna make sure that you can verify all of those and validate that. You're procuring and building the system components, right? And you're verifying the component capabilities. So all of those you're keeping in consideration. You already did the big part of the project, so now you're kind of touching up and focusing on things. There's still a lot of work to get done before you're going to start building, right? But now you're really you're getting there, and so you're preparing for post-launch, and that's what you're going to start building, right? Okay, so now you're in the building phase, and that's the system assembly and the integration, testing, launch, checkout. So here is where you're going to go from the CDR and then start actually taking everything that from all other systems, from all other departments, if you want, and putting it together in a sense, under one big idea. And so you go from developing things in subsystems, and then you want to incorporate it into one, and you want to make sure that it works when it's in that system. So there's also things like vibration testing. You're going to cool it and heat it so you can have the extreme temperatures in space environments, right? Or if you're doing it with the iPhone, you're going to maybe start putting the parts together and having all the different tests for Earth conducted. Sorry. So that's charging it for a set amount of time, seeing how much the battery, stress testing, right? How the battery performs. So the resulting integrated system is verified and validated, and that's what you're looking for. And it's placed into operations at the end of this phase. So you're really looking to operate this thing at the end. And so here is where you actually integrate the blocks, right? And you train the operations personnel to really focus on getting this thing up and running, completing all the plans that you need to complete, and verifying any external interfaces like, launching site, ground antennas. Are you going to use the deep space network to interface with it? A lot of satellites use that. And so you really want to now flush down the little tiny nitty-gritty details. You're deep in the weeds. But now you're clearly building, you're testing, you're integrating. It's all, you're stuck, you're in budget, you're in budget and on schedule. So that's a more mature phase of the development. And so now we're looking at the operations, right? And in operations, that's where you're gonna send that thing. It's gonna launch in phase D, right here. And now it's up in space, it's up in orbit, or it's in the hands of the consumers. You launched it, you shipped it, you figured out how the supply chain is going to work, how you're going to deliver it to the stores, how people are going to get it in their hands. You developed all the different marketing strategies, everything's set in place. You have the device, you've tested it, people have it, in phase D. You've actually validated that this thing works and people use it on a day-to-day basis. Your whole company is using it at this point. And everything is looking good. Now you want to send it up, or you want to launch. You launch it, and everybody celebrates, everything goes great, you did a great job. Now it's in space. Now what do? There's more stuff to be done. And just sit there and look at it, looking pretty. You actually do stuff, and you do more of the same. You go back and you do all the system engineering stuff. You go back and you test every single part that it's working, even in orbit. You test out that this thing is going to last for how long you trained it to, or you designed it to, right? And so you want to include the operating system through its defined lifespan, in other words. And it includes performing both nominal operations as well as contingency operations to preserve the health of the spacecraft and ensure that its continued science data throughout the whole mission life cycle. And what that means is that you're trying to get the data that you need during that mission. And that's why you have this thing last for that long, because you're looking at a year, let's say, or at 5 years, and you want to get that data that you need during that time. Otherwise, you didn't meet the baseline from phase B, right? From right here. So you're making sure that you have everything established, right? And you're gonna also take into consideration all of the anomalies that might impact your operations, right? So you're also making a documentation, and more people are going to come in and review, and that's an ongoing process. And you keep doing that even when you get to the closeout, which is what we're going to wrap this whole thing up with. And even closeout, there's things that you need to do. There's a final archival of the data. And what that means is that whenever you finish, let's say you want to retire something, you need to have a plan of what you're going to do when you retire it. So how are you going to make this data available to the public? Not even, sometimes to the agency, depending on who's launching it. If it's the military, it's throughout the agency, right? And if it's NASA, you're spreading it across the globe. So you want to make sure that you have an idea of how you're going to do that. You also have the budget, and you also have the resources to do it, right? And so you're retiring your satellite. It's going to be there. How is it affecting other satellites? Is it going to be in the way? Is it going to crash into them? Is there going to be any radiation or interference that's going to result from that satellite? And so you're thinking of these ideas when you close out something, and that's also very important because you're always looking to help other people build their own things and learn from what you've built and from your mistakes, or learn from how you did things really well and how it worked. Because maybe they're building something similar, and instead of going and doing everything from the beginning, they can build on top of what you did. And that's how you wrap things up. I know it's been a little bit too heavy but that's only 2 sections that I've covered. So I really wanted to focus in on these 2 sections, and I wanted to make sure that I really got into the weeds and explained every single part, because I find myself doing this very often, and doing this to 1 or 2 or 3, like just a handful of people. But I really wanted to take this opportunity to broadcast it to a whole set of people so that you can do the same, and I don't have to keep doing that. So I really wanted to make sure that I covered all of that, and I want to thank everybody for the time that you've given me. I don't know if I'm on track. I have no idea. Oh
yeah, we have like
no,
we
you're
have
good.
like 30, we have like 30 more
Okay.
minutes. We can if we can brush on the things that you're doing or you did, or like
Sure.
The spin-offs of the things that you created or the things that NASA create, like, because I think that would be also an interesting topic. but according to, but based on everything you said before, I think everything was clear. We were able to understand that, and yeah, it's really, really important. I've seen people when I'm working with my projects, we usually struggle with these things that we don't really usually think about. Like, we know our technical expertise, we know everything else, but like these little things that you talk about, I think these are really important to be kept in the back of our minds every time we're pursuing a huge project. So yeah, I'd like to thank you for your explanation of all of that.
Appreciate it. I tried not to
Add my
go
feedback too.
Yeah, sure.
too
Go ahead.
technical. Oh, go ahead. Go ahead.
Yeah, I think that's very detailed, and I like how you shared your experience that when you first did it and people started running. I like that that part, that funny part of the story. And I would like to add something on what Claudia said about if you could also, like, since we are a little bit focusing also on the Lebanese roots, if you could say, we Lebanese, how can we achieve that, become researchers at NASA or something like that, in the remaining time, of course.
Okay. Yeah, I can cover all of that. So yeah, so firstly, just funny stuff. When you're working on these projects, they take a long time to develop, right? And so whenever you hit a big milestone, people are so excited. Like, they're just they're really excited. Like, I've I've gotten calls in the middle of the night of like my teammates just like, oh my God, it actually worked, and things like that. It's these crazy things that that you experience. It's like a rush, right? And it's really, when you're working with a big team and you see everybody happy, it makes all of the hard stuff you're trying to, that you've been working on, kind of like go away, like so also I want to say something, because everybody here is going to be a leader or is a leader. And what I've noticed is that whenever things go really well, the whole team celebrates. But whenever things are kind of tough, the leader has to kind of own up to that. And so it's one person that takes the fall and a lot of people that celebrate. And so just keep that in mind, because I believe everybody here is a leader in their own discipline. And yeah, look out for your own team. I think that's very important. Just look out for your own team. And no matter where you are in the world, even in Lebanon, if you're looking at, okay, this sounds really nice and dandy, and I would love to do all of that, and how would I really get into the weeds and try to do that? Well, there's a few things, there are a few options for you, right? So if you don't own any of, so for this type of work, it's a lot of governmental work, right? So you're talking, you have to be a U.S. citizen or have some type of, permanent residency of some sort, to be able to do this type of work here, because it involves high-powered rocketry. It involves, the space-grade equipment and things like that. So
Yes,
you can't just
totally.
give that access.
Yeah.
Right. So, but however, other countries also have space programs, and they all follow something very similar to this like systems, engineering, and project lifecycle. They all do something very similar, even China, and everybody does the same thing. And so so there are a lot of countries that do that. And more recently, in the Arab world, in the Middle East, they've been sending rockets. At least they've sent at least one, right? So I know for sure that
That's true.
they have a space program. And so you can look into that, because if you don't have any papers, but if you do, you have, you can come over to America or even go to Europe, right? If you're on the European side of things, ESA is the European Space Agency. And you also have obviously NASA, but the thing is about how it's different, right? Is that you have companies that are competing for contracts now. So now you don't only have one option is to go the government way. You can have another option. You also have another option is to go
I mean,
any
private
company.
companies.
Yes. So you're talking, the more famous ones, Blue Origin and and SpaceX, and the less known ones are Relativity Space and Firefly, things like that. And so you really have some options out there. And you can also go to labs. So national labs that develop these types of things. And, you're talking like jet propulsion labs and these sort of national labs.
So what you're saying, we can't directly like become researchers at NASA if you don't have the citizenship. Like we have to find other options.
Yeah. So for NASA related work, I think you should have a level of I think it's either like a permanent visa or something like that. I'm not too sure. I can double check that for sure. But you should have some level of being American to some degree. In other words, because you're dealing with you're dealing with like you're putting this thing on a rocket, like yeah, that's a national security type of thing. So you should be American to some degree, I think, to be able to do that. But there's a lot of other really great programs out there that are
so basically private companies. We don't have
no. So if you're looking at America, yeah, sure, private companies, but even private companies can't hire you for that type of work. So if you're looking at SpaceX, they can't even hire you even if you're if you're not American. So that's why they hire mostly strictly Americans for that type of work. So yeah, but if you're looking at for other countries, they do have great. So I believe a lot of rockets shoot out from Asia, Central Asia, Far East Asia, things like that. They do have Kazakhstan, one of the countries. They shoot out rockets from there. It's crazy. And astronauts, American astronauts, they go there and they get sent up into the International Space Station. So they go into orbit straight from there. So there's a lot of good ties between countries when it comes to space exploration and development. And people are really, really, they really want to help out and work together. And so there's international collaboration if you want. And so I really encourage you looking out, depending on what country you're from. It's probably from all around the world. I haven't really looked at the participants. I probably wouldn't know. But there's people, there's things, there's programs in countries. I encourage you to look for every region. If there's not in your specific country, it's probably in the region. And so like in Lebanon, for instance, you can look in the Middle East and see what's going on there. Because I know there's a lot of investment in space. And I've spoken about that with some of my colleagues, things like that, and they're looking to see if things are more lenient over there. Because here, you saw how much you're trying to accomplish just to build a satellite or something, right? And so maybe they're a little bit more lenient, although it might be a little bit, they're willing to take more risk, right? But it's things that you want to consider. But it's also that they're going to use this as the word of the day, baseline. So they're going to use this as a baseline, right? And I hope that this thing, no matter where you go and no matter what discipline you're in, you can use this kind of chart or table to really help you. And I know I didn't go into like the footnotes and stuff, but those are now easier to digest once you've gotten the bigger portion done. And so no matter where you go, you can still dream of things. And some of the things that I dream of are humans in space, plants in space, and the economy as we scale up and go into space. And so things that I'm excited about are printing human tissues. I think once we establish some residency in space, some either on a moon or on a planet, we're able to
That would
have
solve problems, I think, but also create ones too, like, residencies on other planets. But that's another topic, right?
sure, yeah, it's pretty complex if you want to really
Yeah, exactly.
boil it down. But yeah, so printing human tissues, I think something is exciting to me because I think once you do that, you're then able to print maybe larger organs and things like that. And as you progress, you can maybe that when I think of time travel, I think of instead of shipping something, maybe shipping is included, but then building it on site in situ, in other words, could really help out making it faster. So you maybe ship out the initial ingredients and then you build it on site, and that's going to really. But before you go into humans in space, being able to print an actual human on Earth is maybe like step one or step zero, and then doing that in space is maybe the second step. So that's something a little bit too further out, but that's something that I'm excited about. And the plants in space is something that I'm currently working on. Essentially, I want to have a biosphere. What a biosphere is it's all the different parts of the environment. And so the reason why it's interesting to have plants in space is because you're breathing life into nothingness, and that's something that is fascinating and very tough to do, because plants love living on Earth. That's why they love water, so and carbon dioxide and things like that. So trying to mimic that environment in space is both challenging, but it gives you a lot. So I've worked a lot with Kennedy Space Center and currently under contract for developing this thing. We're calling it Plant Pod, but officially it's a research platform for life sciences. And it also, another team is working on microbes. So that's something to consider, giving you some insight on what's going on and what people are trying to develop. And so we're looking at lunar orbit because there's extremes in the environment. It's really, oh, somebody raised their hand. Go ahead.
Yeah, go ahead, Nicola. I was enjoying, so I raised my hands and waiting to finish your talk. So please go ahead.
Oh, sure. Yeah, finally, the economy in space. Having a supply chain for both energy and resources is something that I'm excited about. What that means is establishing a proper business model, be able to collect both data and actual resources, so raw materials and things of that nature, and being able to transport it back to Earth and making a profit out of it. So essentially, building things that people buy is how you get your project out there to a certain degree, right? You might have a little patent or something just there, but if you actually want to have it as a project, a profitable product, then it's something that can give people a return on investment. And that's what people have been doing so far with space exploration and development. It's bringing that price per pound down as we progress, right? So having building cheaper, more reusable rockets is one way to do it, and then establishing some residency or some base in space, either on a moon or on a planet or on an asteroid if it has a gravitational pull and some atmosphere to shield you, then you're looking at to decrease that expense and to bring down the cost per pound way down, because that's going to be able to help exploration increase exponentially. So that's the only way I believe to do it. And if you're looking to send people really far and wide, I think computers are way faster at, and that's from my background of computers, they're way faster at kind of progressing progressing through space and collecting that data. So something that I'm a big fan of is self-replicating systems. It's essentially a system that replicates itself or replicates at least a portion of itself to be able to, build other more complex systems. So I'll make it a little bit more tangible and say you go to the moon. You can't send everything, but you might send the tools. So essentially, it's kind of like building a house. Instead of shipping the whole house, you might ship the tools to build it and then carve out the resources from the surrounding environment. And so when you're looking at a self-replicating system, you might ship out the core components, but then the rest of the stuff that you can build there, maybe you want to consider building there. So that's also a part of my work. And I hope to maybe accomplish that at some point. Maybe that's like a stretch goal. But yeah.
Can I ask you a question?
Sure.
Mansoor, please, because there's been a question in the chat for quite some time, can we just, because it relates to the slide before.
Sure.
Yeah, there's a question asking, like, have agencies such as NASA started embracing agile methodology for project management? So agile methodology, I think where you do something and then you go back and then you go back.
Yeah, so if we go back just a little bit and we look at this little thing, this is made so that you can do that type of agile work. So it's not a waterfall. So that, what do I mean by that? As in, when things go from top to bottom, you don't get stuck on the bottom. You can actually go back and fix stuff and then go back down. So so we were talking about the preliminary design review. That's right here. And I'm going to give you an example. Let's say you did come up with a great design, but there's some tweaks that you need to figure out, flush out, redesign. Then you can go back and work on that. So you're always getting constant peer reviews, and you can see that on the bottom. Those are peer reviews and subsystem PDFs and things like that. And so critical design reviews, right? And so you're getting that feedback, and it's constant feedback on every single phase and every level, so that when you're building something, you test it or you have it reviewed, and then you go back, and if it's not good, you go back, you fix it. If it is, then you can progress forward. And so it's always this cycle. So it's not a waterfall in a sense. Otherwise, it would be very, very costly. And I don't even think any space technology would be able to develop, at least not in this type of time frame. Well, great question though. Fantastic question. Any other ones? Yeah, sure.
Yeah.
Oh, is it my turn?
Yeah, Mansoor, your turn.
Yeah.
Oh, okay. Thank you. It was a really inspiring presentation. Thank you for this. Yeah, the question that I have been asked most from the people in our events. So especially for this space domain event, a question might come to mind of many people that agencies like NASA, SpaceX, or any agencies around the world who are looking for talents or candidates to boost their projects, what kind of skills is the most hot one? What is the so for example, for electrical engineering or computer engineering, people might ask from themselves, okay, what I need to achieve during my studies or after my studies to put some new lines in my CV to impress those agencies, to be more attractive to them. So what do you see, like from your experience, that the people you are working with?
That's a great question. What I've noticed is, well, first off, I'm very fortunate to be surrounded by some amazing people. So I work in a Texas Instruments lab currently, and I help people build rockets and robots and planes and things like that. And so every single day, people come up to me with problems, and it's problems that I've never considered before. And so it's every single day I get a new set of problems that I'm trying to address. And I've noticed that over time, going from being overwhelmed with the amount of problems that exist, I'm able to quickly find solutions to their problems, or even point them in the right direction as to where to get the solutions from. And so that can be a software problem, it can be a hardware problem, it could be a design problem. And you're able to really address that in a clear way. Because what people, when they come to you with a problem, is they don't want to be more confused as before they came. You know what I mean? They don't want to be more confused after talking to you. So the only way that I've discovered an effective way to do that is to actually go ahead and try to build what you're building. So or build what you want to do. So a lot of the people, like I said, around me dream of making a rocket. And so they go and they make a rocket, and then they fail maybe for like a few weeks. And so, or months trying to build, if you're different, and there's different types of rockets, by the way. There's like, different levels of different engines and all that. And so, and you can get certified for them. But essentially, they're really trying on one project. So you choose a project and you try to get it done. And when you fail, you learn. But the most important thing is that you keep moving forward, in a sense that you keep learning from what you built. So kind of like what we were looking at earlier with this little chart, you keep learning from the previous things. And I think for any organization, specifically for things related to space, you want people who can actually do things. And no matter what you do, if you're an electrical engineer, computer engineer, mechanical, aerospace, civil, industrial, even photonics, be able to choose something and be able to actually do it and work on it, even though it's hard. Because most of the time you don't do things because they're easy, and you do it because it's hard. But there's a lot of people that are willing to help you out. So don't be afraid to ask for help. And people are really willing to help out. So I think choosing one project is going to greatly build your skill set in ways that you never thought you were even considering. So it's you might learn a new language, a new programming language, and you might learn how to use a modeling software. Or if you're laser cutting, now you learn how to make things in a 2D fashion so you can laser cut. Or prototyping, 3D rapid prototyping, or 3D or 2D rapid laser cutting, or even soldering. You might learn how to solder. And so, but it really depends on what you want to focus on. So like, let's say you want to, depending on each project, you're going to have skills that are going to develop through that project. So I would recommend for people to pick something, pick whatever you want, pick something that's in your means and you can build it. So I see a raised hand.
Yeah, just want to say, because we're really almost reaching the end of our talk, if you're available for some extra time, because there's a bunch of questions to be asked.
Sure.
Yeah. And one other thing, if you want, you can raise your hand and you can actually have the mic. You can ask your question right here live if you don't want to put it in the chat. Okay. And I see a question.
Meanwhile, Jessica is asking something. She's giving you a feedback, by the way. Thanks for your in-depth overview of the project life cycle. It's really going to help me in SCAS in February. I just have one question. What are some of the biggest mistakes you've seen or you've seen others do during project development?
Okay, I was a part of NCAS, so that's super, super cool. Okay, so things that I've seen, mistakes. I think communication. I think communication is really key. If you don't have a proper line of communication, understanding things are very tough. So you want to make sure when you're speaking with somebody, sometimes maybe a good pointer is to repeat what they say, just to make sure that you really got what they need. Because sometimes, you know, they might say something that that you, oh, sweet, just here from February Uncas. Okay, cool. Oh, that's great. I'm so glad that you guys are here. I hope that this talk really helped you wrap your head around things. Yeah, so communication, I think sometimes a lot of times it's like it really impacts your project sometimes negatively because communication can be tough, even especially when you're dealing with multidisciplinary teams, as in people that work in different fields, and they might think you know something, or you might think that they know something, and it's not really the case. And so you really want to have a clear line of communication, and maybe every meeting have an action item, sort of like an action list. So these are the things that we're going to get done, and this is what we agreed on, and this is actually what you want, this is actually what I need, and things like that. So you want to have a clear idea of what's really going on. Communication is very important. So would the recording of this seminar be also available? Yes, I think people are recording this. So it should be available, I think. I don't know how. So you might want to ask.
Yeah, we'll take care of that. Don't worry.
Okay, cool.
Also, we have Logan White. He's raising his hand if you want to ask a question.
Hi, Nicholas. Thank you so much for this amazing talk. I noticed that you attended the Space Academies when you were in college. I just wanted to ask, how did your time in those academies build your skill set for what you're doing now?
Hey, that's a great question. I can think of two main ways that they've helped me. First off, team building and team leadership. So I think I was project manager for both of them. And so as a project manager, you have to make some really hard decisions, and those really prepped me to like make these hard decisions. And it's decisions that affect people through time, and that's, I think, is very important. It's not just one person. You know, you're affecting, like, let's say a team of 5 or a team of 10, and so you're affecting a good amount of people. And it's through, like, let's say a few months of development. And so that's in one way. And a second way, more technical, is proposal writing. And I think largely because of the space, I was able to get a contract from Kennedy Space Center to help build or to have pretty much kind of control over my design of a spacecraft. And so I think it's proposal writing and teamwork. I think those two main things just stand out right out of my head. I don't know what else. I feel a lot of things, but those are the two main things. Does that answer your question?
Yes, definitely. Thank you so much.
Sure. Yeah. Any other questions? If you don't mind, I do have a meeting with the Navy in a bit. These guys are kind of punctual.
Yeah. Okay. Also, I think
the last question, Nikolai.
Sure.
Is there any alien?
Oh, that's a great question. So actually,
no.
I keep asking this question to everybody I meet.
Did you visit them?
So I keep asking this question to, like, a lot of people that I meet, you know, higher ups and things like that, and project managers and stuff. So, but what I've discovered is that if they did discover any, there would be more investment in space. So as in NASA would get more than 0.5% of the Federal Reserve. So currently, for like every dollar NASA gets, not even a cent, half a cent. So they would have more investment in space. You would quickly see the investment, just the Federal Reserve reallocating a budget to space exploration and development. So
that's the sign. That's the sign to see if there is any alien.
Yeah, just keep an eye out. Keep an eye out on the economy and how things change. I think that's going to be your leading.
And Mansoor, how are we going to give them the recording and the slides? Like, are we sending the link by email?
I think what we're gonna do, we're gonna upload on our YouTube channel, and then we share with the student branch of Lebanon and YP Montreal.
Yeah, sure. I'm
then
glad to hear.
And then we just post in our LinkedIn, and they can just follow from our LinkedIn to get the link.
Okay, perfect.
Fantastic, yeah.
Okay, Claudio and Melissa, final words. I'm just going to turn off my mic.
Yeah, sure. So, Nicholas, man, thank you very much. It's been a long time in the making, and I'm really glad that we were able to do this event and you were able to share these amazing ideas with us. And we'd hope to have you for another time in the future when you get even more stuff done, as I'm sure you will. And yeah, thank you everyone for coming here. Melissa, if you want to have some words.
Thank you so much. I really enjoyed the meeting. I hope also the people from Lebanon, from my student branch, also enjoyed it. I'm gonna gather the feedback and send it to you so that you know exactly what everyone thought of it. But so far it was everything but summed up.
Please critique me, because that's the only way I can progress. So please don't be afraid to critique. Okay.
Yeah. And exactly like Claudio said, he said it all.
Thank you guys. Thank you everybody for attending. Thank you for having me. I look forward to doing this again, if anything. And I'm really glad.
Yeah, let's keep in touch for future events, of course.
Sure. And I'm really glad that you got your time's worth, I hope. So
yeah, I'm sure everybody did.
All right, thank you. I hope you guys want a technical, so I hope this is technical enough. Unless you want me to go more deep in, I can start putting up code.
I think that was great. Like more technicalities, I think people I would have got lost.
We're just zone out. All right, I appreciate it.
I don't know if we can discuss some particular projects without voiding any non-disclosure agreements, obviously, but it's something that we can talk about in the future. There is no rush about that.
Yeah, maybe future events.
All right, deal. Thank you so much, guys. I appreciate it.
Thank you, Nicholas. Thank you, IEEE Montreal. Thank you, everyone.
Thank you.
Bye-bye.
Bye-bye.